All right. Do we need more time? Okay. Okay, no, we're good. Okay. Okay, my microphone that I usually wear is dead, so you'll have to be a little bit quieter while I yell at you. So, number one, what is the pH of this buffer to start with? Anyone bold enough to just say it? 3.63? Ooh, that's my address. That's creepy. Maybe. Well, most of you know right where I live anyway, because I drive there, Greg drives there, Jesse Roberts drives there. Everyone drives past my house and drives in. All right, so were we good with that? 363? All right. Then, after the addition of HCl, so this is acid, right? So I have B over A. If I add acid, A goes up and B does what? Goes down. Fair enough? Okay. And it goes up by the equivalent of the number of moles you added. So 0.001, correct? 0.01. Okay, thank you. Sorry. 0.01. All right, so that adjustment gave you what new pH? 3.58. Always double check for reasonability. Did it go lower? Yeah, like that's the only thing you can really check. It went lower and it didn't go very far. Are we okay with that? 3.58? Okay. Next. This one, a buffer is made by adding this. What did we end up with our answer here after we've added this? 1.8? That's what I said. 4.8? Hey, even Benson felt good about that. That means a lot. Okay. Did we have a problem there? Okay. Yeah, you didn't have to do the first part because it did it for you. Well, yeah, okay. Okay, 4.8. Put your name on them. Let me grab them so I can give you some points. Okay. Up until now, I told you something was a buffer, and I gave you something weak, and I gave you the conjugate. All right, and you knew it was a buffer because I told you it was. Well, now we got to learn some chemistry. And we can do it because we're super bright people. We've weeded out all the morons. That was debatable, huh? Just kidding. There were no morons, but we've weeded out the kids that don't want to do anything. Well, that's not true either. We've weeded out the ones that were smart enough to realize that they hated this class. Okay. So if you look here, we have to think about the chemistry. So it says, is it a buffer? Letter A, we have 30 milliliters of HCl and 3 grams of NaOH, or why did I say that? NaF. All right, the first thing you need to do is find the number of moles right here. Okay, so we got to convert grams to moles. So I take 3 grams. I'm going to have to divide it by grams, right? Because I got to get rid of grams. I have moles on the top. NaF is 42. Is that right? Okay, good. So this is 1/14, whatever that is. 0.07. That sounds about right. All right, 0.07 moles of NaF. Okay, are you with me so far? If it gives you grams, you got to convert it to moles. So right up here, I'm going to erase all this stuff again, but I have 0.07 NaF, and that's moles. And then right here, how many moles of HCl do I have? So I have to be in liters. 0.03 times 0.2 is 0.006. Does that sound right? 0.006 HCl. Okay. Now, the next thing to do is we got to use our chemistry brains, and we look here and we think, would any reaction here cause any type of weak acid or base to be formed? So you got to look up. Please remember, we can ignore Na and Cl, right? So now we ask ourselves, will HF form something that is a weak acid or base? Yes. HF is a weak acid. Okay. Now, please follow my logic here. The amount of acid will be equal to the smaller number because it's your limiting reactant. You okay with that? To make HF, we need both of H and F. So whichever one is smaller, that's the amount of acid I'm going to make. So this has how much HF in it? All right? Now, so we're halfway to a buffer. A buffer needs a weak acid, and then it needs what? Yeah, it needs the conjugate, which would be F minus, correct? In this problem, is there any excess F minus? Yeah, there's a lot, right? There is 0.0694. Did I do that right? Because for some reason, decimal land, I screw up my math. How did I get that number? Okay, it's the difference between the big and the small. And that's moles of F minus. See, I don't know why have you noticed I do struggle in decimal place land? I do. All right, thank you. Sorry about that. All right. Okay, so now we know in my beaker I have some HF, not very much, but I have some F minus. Is this a buffer? Yes. It is a buffer because it meets the requirements of having a weak acid or base and the conjugate of that weak acid or base. HF is very common. It's not always, but it is very common. Same with acetic acid, so HC2H3O2, really common to have those two. Okay. Weak acid or base. Okay, this one happened to be an acid. All right, and the conjugate base. Okay, now, once again, it's a buffer because if we add H, it bonds to this, right? If we add OH, it can react with that to make water and just free up more F minus. Okay, so it is a buffer. Now, it will always be a buffer as long as these conditions are met, but they're not always met that way. Okay, by the way, we could now find the pH of this. How would we do that? We do have to have that number. Anyone know what that is? Ka for what? Oh, good. Thank you for stepping in that trap. There is no Ka for HCl. Hashtag love you to death. Okay, so don't get offended. But remember, if it's a strong, we don't have a Ka or a Kb for it. So what do I really need for this problem? The Ka for the acid that was made that's part of the buffer. So to find the pH, I take the negative log of the Ka. Say that again. No. On a question like this, and you have one like this on your test, I give you a table, and it has a bunch of Kas. More than you need. In fact, it has a fake Ka for HCl, and at least 30 to 50% of kids use it because it's right here. You're like, oh, HCl is the acid in this problem. False. HCl provided the H that F reacted with to make the acid I actually care about, which was HF. Okay, now I take the log of base over acid. Which one of these was my base? F minus. Which one was my acid then? HF, and then I'm just ready to roll. Okay, so it's really not the math that gets you. It's the chemistry. It's knowing, am I making a buffer, and how much of it am I making? Now, through practice, this comes pretty quick, but it's kind of a pain. Okay, now, let's look at the next one. The next one, it gives you HF and it gives you NaF. If I just ask, is this a buffer? This one should be easy to answer. Is it a buffer? Yes, because it gave you the weak and its conjugate. Good? Okay, now letter C. Letter C and A are very similar, but they have different values. And the values absolutely matter. Okay? So we're going to do C just like we did A, but we have different numbers. So this one's 20 42nds, right? 10 21st. Yeah, the amounts, because, well, we'll talk about it. But if you don't have excess F minus or some acid made, the reaction doesn't, well, it happens, but you don't have it. It still works. Yep. Okay, 0.476 moles of NaF. And I'm just going to put F minus because we don't care about Na, right? All right. HCl, it's 1 times 0.2, so that's not too hard. We have 0.2 O of H plus, correct? Okay. Now, looking at this, will a reaction happen that will create something weak? Yeah, we already did that in part A. The amount of acid produced is equal to the smaller value, correct? All right, the smaller value is 0.2 HF, and the difference between them would then be 0.276, and that'd be F minus. So now we would say, is this a buffer? Yes, it is. All right. I thought I had one on here that would not be. Oh, geez, that does say 0.20 milliliters. What a terrible way to type that. Thank you. That is 0.2 milliliters. So we better change this one, right? So really, that is 0.0002, isn't it? Except for it's a decimal. Okay, so now we're 0.0002 HF. All right, and then what would this be? .4758. Okay, still a buffer, right? Because we still have weak acid. We still have F minus. What's that? Yeah, right here. And then it still matters. Because remember, this is really 2 times 10 to the negative 4th. But sometimes we go to the negative 14. So this is actually, even though it's really small, it still is a thing. Because when we talk about concentrations and all this stuff, these small numbers, it's okay that they're small. Okay, so that's a buffer. We could calculate the pH. How much time we got left? 8 minutes? Okay, we'll do this one. The answer to this one is no. Just by looking at that one, we can tell it's a no. Now, you might not be able to, but what you do is you look right here. Is HCl strong? Yeah, it is. Is KOH strong? Yes, it is. So, if both are strong acids or bases, strong acid and a strong base, then they will never combine to make something that is weak. Because every single piece of this is more comfortable being dissociated. You okay with that? So, if they're both strong, then nothing will happen. Okay, so you would just say no. And if it asked for what the pH of this was, we need to do it because it will. So it asks for what the pH is. You do not use Henderson-Hasselbalch on this. Okay? You use, okay, don't draw a marker. I don't even care if you do, in fact. Okay, we don't use Henderson-Hasselbalch because this was not a buffer. So this is how you do it. You find the moles of H plus and the moles of OH, and you find out which one is in excess. Oh, it doesn't even say. Well, let's call it 1 molar. I was really lazy here. Okay, so we'll say it's 0.05 moles HCl. Oh my, what is wrong with this thing? Okay, and then we'll say it's 0.02 moles OH, because I really don't care about the whatever. All right? Now, when you look at these, the base and the acid will neutralize each other. I gotta move. It's been fun though. All right? They will neutralize each other and leave something excess. So what you do is the amount of water produced will be equal to the smaller number. See, at 0.02 moles of H2O, which we don't care about, we care about the excess this time. That leaves 0.03 moles of H plus extra. Okay? Then we come up, we need concentration. We will take the negative log, but this is moles. So we first then would divide this by the total volume, which is 0.07 liters. Okay, that's 50 plus 20. And someone type that in for me. $429. Okay, and then I just take the negative log of that number. What's that? 0.368. Wow, that's a super acidic solution. All right, so the process here, if they're both strong, or strong, whatever. If they're both strong, you find the excess and then just do the negative log. If it was OH, that negative log would have given you POH, right? Okay. Oh, I can undo it, I think. Where's the undo button? It's right there. Hold on. Okay. Now, there are definitely other times, and we'll see how far we get, when it's not a buffer, but it looks like it really is a buffer. So, if we look and we just switch these numbers, I think, well, let's say 1 gram of NaF. And to make this work, I'm going to exaggerate. In 100 milliliters of 10 molar HCl. All right. And then we'd say, is this a buffer? And it's going to be tempting because we have HF, correct? All right. But it won't be a buffer. I'll tell you why. All right. We have 1 gram over 42. That's the moles there. And then I have 0.1 times 10. So I have just essentially 1 mole of HCl, correct? And what's 1/42? 0.02. Okay. And that's my F minus. This is my H plus. Oh my gosh. Can't move much closer. All right. Now, let's think about what happens. We make acid equal to the smaller value, right? So how much HF do we make? 0.02 HF. All right. How much F minus is left over? 0. Oh my heavens, that's supposed to say 0. Is this a buffer? No. You have to have excess F minus for this to be a buffer. So how would we find the pH of this? Kind of like the last one. We made 0.02 here, so we subtract 0.02 from 1, and we get 0.98 moles of H plus. You would divide that by the total volume. Did I even give you? Oh yeah, 100, right? No, sorry, 0.1, because that's be liters. All right, so that's 9.8 moles. We take the negative log of that, and you're going to get a really acidic solution. 0. It's what? Yeah, it's not a thing. All right. What was it? Well, negative 0.99. So that's not a thing. But I super over exaggerated this, okay, to make sure I knew this would be a 0. If you don't have conjugate base, you cannot have a buffer. Now, whenever I say that, the same goes if all of this was for a weak base. If I had the weak base and I didn't have the conjugate acid, we wouldn't have a buffer. Okay? So if your conjugate runs out, then you just find your amount of H plus, negative log it, and you're off to the races. Okay? So this is the part that is hard, because I'm going to give you these. I'm going to ask if it's a buffer, and then if it is, I'm going to ask what happens if you add such and such and such and such. That makes sense? This is typically like a 9.8 on a scale of 10. Now, I don't think it's awful, because we've done all this stuff for a year, but typically this is the hardest, and then some stuff in chapter 19. Okay, 5 more minutes? For some reason I thought we were at 9:35, because of mine. Let's see if we have others. All right, we did those. Okay, here's kind of a summary, and it's ugly, but we can talk through. What's that? Yeah. This mic's on me, just not the classroom mic. All right. So, once again, conjugate base in excess, it's a buffer. And that's the most likely situation. Next, if H plus equals conjugate base, then it's weak acid. Once again, you solve for X and take the negative log of it. If H plus is excess, we just find what that excess is in molarity, and we take the pH equals the negative log of that excess. Okay. Sound all right? We'll call that good.